Next up, we're going to actually find our morning star fix. I know I said before that when you take shots, star shots, you should do a lot. You should get at least like 6. But for simplicity's sake, that they only provided us 3 stars here that we're going to be working off of. Before we begin, you could see they were taken at different times, 5:43 to 5:55. Arguably, that would then, you would think that we should probably do a running fix off of this. And I've seen debate here and there on it. Some teachers say that yes, you should advance these stars and you should do it differently than you do with the suns, because there's a way you could advance star shots that's just a little bit less cluttered because you're moving the assumed position, not the actual LOP. But then I've had other teachers saying, like, at this scale, this is 60 miles right here. The difference of 10 minutes doesn't matter. You're not going to be able to see the difference there. I mean, 10 minutes at 15 knots is probably just about 2 miles. At this scale, that's 2 miles is that. It's not that big a deal. So for the purposes of this problem, we're just not going to advance them. And we should still get a pretty reasonable triangle off of that. I will say in advance, I was not able to find with any certainty the index error and height of I for this for this running day's work problem. So that might mean that all of our answers are slightly off. But I was able to find, I think these are the correct values of 0.3 on and a height of I of 54 feet. If that's wrong, it's going to mean that most of these come out to be not perfect fixes. But if anything, I'm just going to use that as my excuse if I make any mistakes, that's where the error came from. We'll see, though. All right. With that out of the way, we're actually going to start doing these star problems. So we took shots of Doobie, Capella, and Rigel and got these HSs. I would have liked if one of these were planets, but we didn't get provided a planet. So we're going to have to work through the star shot for all 3 of them. Now, if that frustrates you that you have to write, you're going to have to do all this work for all 3. A lot of people, what they'll start to do is they'll kind of create like a, I don't know how to say it, almost like a production line model for this, where you're going to do all 3 at once next to one another. As long as you can keep them separate in your head, this is totally fine. It is possible you could accidentally move some of these values over, but it also makes it easier because some things like the hourly GHA is going to be the same for all of them, so it kind of simplifies the process for a bit. Okay. So if we write out the table here, just for stars, it's always going to be the same. We're going to start with our time calculations. Now, this problem didn't give us chronometer time. It's only using zone time. So makes your life a little bit easier. But remember, if it were necessary, we'd have to start with chronometer time, chronometer error. Here, we're just going to do zone time, zone description, GMT. Okay. So as you can see, if we pull it from the paper, Doobie had a zone time of 05:43:50. Capella had a zone time of 05:50:06, and Rigel 05:55:55. Now we've already worked out from our morning star time problem. We know we are in ZD minus 11. Sorry. And that's true for all 3 of them, so we can quickly run through and subtract 11 hours from 25, or from 5, which easiest way to do that is to be 24 plus 5 will get us 29. Subtract 11 hours, and that gets 18. So our GMT time is 18:43:50, 18:50:06, and 18:55:55. It's important to note we just went back a day. So this is all on the 3rd of November. So when we go into the nautical almanac, make sure you're working off the 3rd of November, not the 4th. It might be the 4th of November for us, but we're way out ahead of the international date line, but before Greenwich, so that we're operating a day later. All right, now we'll open up our book back to November 4th and November 3rd now. There we go. All right. We have the Nautical Almanac open, and now that we've got our GMT time, our next problems are to get GHA hours, minutes and seconds, and I should note that this is GHA of Aries because we're doing stars. Then we'll get the GHA of Aries itself. We're going to add on the SHA, and then we're going to get ourselves our the GHA of the stars of the star itself. We're going to then compare that to our assumed longitudes and get our LHA. Now, the hourly GHA is going to be the same for all of them because it's 1800 for each. The minutes and seconds are going to be different, and the SHAs are going to be different. So some of these things we can carry over, some we can't. So we're looking for the 3rd of November at 1800 in terms of Aries. So we come here. There's the GHA of Aries at 1800. 312 degrees, 34.2 minutes. Or 54.2 minutes. So we'll write 312 degrees, 54.2 minutes on each of these. Okay. Now, before we move on to the increments and corrections, that's going to give us more work if we keep going back and forth between these two pages. So we're going to get everything, all the information we can get from this page first, and then we'll add in minutes and seconds. So the next thing we would need is going to be the SHA. That's going to be listed for each of these stars up here. And we're also going to find the declination in a second. So remember, the SHA for each major star is listed here alongside its declination. So number 1 is Doobie. There we go. Doobie has an SHA of 194 degrees, 21.5. 21.5, right? Yes. Then we're going to look for Capella. So Capella is somewhere up here. Should be, there it is. 281 degrees, 9.8 minutes. 281 degrees, 9.8 minutes. Then finally, we're looking for Rigel. There we go. Remember to not get Rigel and Rigel Kent confused. 281 degrees, 35 minutes. 81 degrees, 35 minutes. Rigel and Capella happen to have very similar SHAs. That might pose a problem later, but they provided the question. Nextly, we need to get our declinations, which are listed here as well. So if we go back to Doobie, we've got north 61 degrees, 50.8 minutes. North 61 degrees, 50.8 minutes. Right, yeah. Capella had north 45 degrees, 58.8 minutes. 58.7. Yeah, 58.7 minutes. And then Rigel is south 18 degrees, 13.3 minutes. South, 8 degrees, 13.3 minutes. Yes. Okay. So now we have our SHAs and our declinations. We also might as well just do assumed latitude right now to get it out of the way. Our assumed latitude, we're going to use the DR position of our star time calculation, which we had 17 degrees 59 minutes north, meaning our assumed latitude, we just round up to the closest. It's going to be 18 degrees north for each of them. Okay, now that we've got all that out of the way, we can actually now go into the back of the book and start looking at these increment and second corrections. So for Doobie, we're looking for 43 minutes, 50 seconds. Come all the way back here. There's 43 minutes. What did I say? 50 seconds? Yes, 50 seconds. We're going to come down to, here we go. For Aries, which is the second column, is 10 degrees, 59.3 minutes. All right. Right here, 10 degrees, 59.8 minutes. Remember, we don't need to change declination for a star because its declination changes so slowly. Okay, next, Capella was 50 minutes, 6 seconds. You can just flip to the next page, page after that. There we go, 50 minutes, 6 seconds gets us 12 degrees, 33.6 minutes. 12 degrees, 33.6 minutes. And then Rigel was 55 minutes, 55 seconds. Page over. Rigel, 55 minutes, what was it, 55 seconds? 14 degrees, 1 minute. (14 degrees, 1 minute). Okay, now that we've got these three, we can add their hours, minutes, and seconds together. So 54.2 plus 59.8 gets 114, which carries over to be 54 minutes. So then we'll do 313 plus 10 gets us 323 degrees. All right. Then we come over here. 54.2 plus 33.6 is 87, which we subtract 60 is 27.8 minutes. 313 plus 12 gets us 325. And then 54.2 plus 1 is going to be 55.2. And 312 plus 14 gets us 326. Good. You can see, obviously, these GHAs are increasing because these happen later in the day by a matter of 10 minutes. Now we can add all of their SHAs to their respective GHAs. 54 plus 21.5 minus 60 is going to be 15.2, 2 minutes. And then 323 plus 194 gets us 517, which is obviously too much. We have to subtract 360 from that, gets us 157. So the GHA of Doobie itself was 157 degrees, 15.2 minutes. Now we'll do 27.8 plus 9.8 gets us 37.6 minutes. Then 325 plus 281, 606, which if we subtract 60 gets 246 degrees. And 55.2 plus 35 is 90.2, so 30.2. Then 327 plus 281 is 608, which if we subtract 360 gets us 248. The fact that the GHAs of Capella and Rigel are so close, like, I think this is going to give us a bad shot because these are going to come out with an LOP really similar. Now we need to do our assumed longitudes. Remember, for each of these, because we want our LHA to come out to be a whole number of degrees, we need to set these so that the minutes will cancel out. We are in the east, though, not the west. So instead of subtracting, we're going to add them together. So we're going to want whatever value adds with 15.2 to get 60. So that's going to be 44.8 minutes here, east. 37 point, is that 8 or 6? I think that's is that 8 or 6? 37.6, okay. So that's 37.6, so we need what that's gonna add to get to 60. It's gonna be 22.4 minutes east. And then 30.2 is gonna be 29.8 minutes east. Then for the degree values of our assumed longitude, we're gonna have to do the same problem every time of figuring out what degree value will get us closest to our assumed, our DR longitude of 162 degrees, 12 minutes east. Well, if you don't want to draw it out, because it would be kind of a pain to draw it out every single time, just really quickly, all you have to do is find which degree values would get you within 30 minutes of that. So 162 degrees, 12 minutes east would be within 12 minutes, or within 30 minutes of 162.44 east, because 44.8 minus 30 gets you 14, so it's actually not within 30 minutes of 162. It would have to be 161, because that's 161 degrees, 44.8 minutes. If you went 30 minutes further to the east, sorry, that would get you to 162.14, which would encompass our assumed longitude. We'll do the same here. This time, 162 degrees, 22.4 would obviously be really close to 162 degrees, 12. And the same would be true for 29.8. All of these are now the closest longitudes we can get to our DR position. I'm sorry if drawing it out makes it clearer for you, but eventually you should be able to get to the point where you can do it in your head pretty quickly. And now, remember, east add, west subtract. We could do the diagrams. Actually, I'll do it really quickly for just one of them to demonstrate that. So if we draw the diagram down here, and we're here, we're in 162 degrees east, so Greenwich is like over here. And then the sun has an, the stars all have GHAs from 157 to 248. So let's just take the average of like 200-ish. They're all generally going to get you over here. And that's our GHA, and that's our longitude. So we're going to have to add them together to get the full LHA. If it comes out to be more than 360, then you just do 360 minus. So we'll do 157 plus 162, because we already know these two are going to carry the one over from adding to 360. We get 319. Then 246 plus 163 this time. We get 409. So we're going to subtract 360 from that. We're going to get an LHA of 49 degrees. Then 248 plus 163, 411. Subtract, we're going to get 51 degrees. Okay. We now have our LHA, our assumed latitude, and our declination. So we can now go into the book and start that portion of the problem. So before we even begin, we might as well set up the table in advance. We're going to get HC, D, HC, then Z, Z plus 1, difference, Z, Cn. Okay. Now that we have all these ready, we can start. We can open up the book. And because all of these have different LHAs, we're going to have to open different pages each time. So it is kind of tedious to grind through all of these. But we're going to start with Doobie. Doobie has, our latitude is 18 degrees north, so we should stay on the first half of the book. And we're going to look for LHA of 319. Right there. Okay, good. So here's our 319 page. Our declination is north and our latitude is north, so we're going to use the same name side. and we're going to look for a latitude of 18 degrees and a declination of 61 degrees. I'm going to come all the way down to 61. Here we go. And here's the information we get. We get an HC of 38 degrees, 11.3 minutes. 11.3 minutes. We get a little d of minus 36.7. We get a z of 23.9, so 0 to 3.9 degrees. And we get a z plus 1 of 22.9, 0 to 2.9 degrees. Good. That's all the information we need from this page. Instead of doing all the math, let's just go get the information for the next ones. So Capella had an LHA of 49 degrees. So this happens to also be the 41 page, so we can skip this way and we'll get towards 49. There we go, 49 degrees. And then Capella has a declination north as well, so we're going to stay on the same name side. We're still using the 18 column, but we're now going to come down to 45 minutes, or 45 degrees of declination. So we get 41 degrees, 16.7. We get a little d of minus 18.2. We get a z of 45.2. 45.2 degrees. We get a z plus 1 of 0.44 degrees. Okay, good. That's everything we need for Capella. So now we're going to come to Rigel, which was 51 degrees of LHA. So here we are, 51 degrees. However, Rigel has a declination that is south. We're still in the north, so now we have to come over to the contrary page. We're going to do our calculations there. Still using 18 degrees, though, for our latitude. We're going to come down to a declination of 8. So there's 8. So we come across, and 8 has 33 degrees, 20.7. 20.7 minutes. Where was it? Yeah, minus 28.2. Then our 112.9. 112.9 degrees. And finally, 113.9. 113.9 degrees. The reason why I was worried about Rigel and Capella there was because if both stars had the same or really similar SHAs, they're probably, they're close to having the same longitude, correct? So I thought what that meant is that there's a strong chance that they were going to have really similar bearings between the two of them, but I had forgotten that their declinations were really far off, meaning that that kind of changed where they were bearing in the sky, giving a pretty clean difference between Capella and Rigel, though Capella and Doobie are kind of close. So now that we've got all this information, we can start to perform the interpolation for them. So for the little d value, remember we have to multiply it by the minutes of our declination. So for Doobie, our declination had minutes 50.8, so do that over 60. For Capella, we had minutes 58.7 over 60. And then for Rigel, it was 13.3 over 60. And then our differences of azimuths, we're actually going to do the same thing. So we're going to carry over those same numbers to each of them. Then we have to obviously find what the differences are too. So we'll really quickly do that. See, 23.9 to 22.9 is obviously minus 1. 45.2 to 44 is minus 1.2. And then 112.9 to 113.9 is plus 1. All right. Now we can do these interpolations. So we're going to do 50.8 divided by 60 times 36.7 gets us 31.1. We'll round that to 0.1. I forgot to leave space. Technically, you should write 2 little d's, so there's kind of space for you to write that. Because I didn't, we're just going to have to immediately apply it. So 11.3 minus 31 plus 60, that's going to bring us down to 37 degrees, 40.2 minutes. Now we'll go on to our azimuth here. We'll do 50.8 divided by 60 times 1, we already know it's already happening. So minus 0.8, we're going to apply that to 23.9 minus answer. Gets 023.0 degrees. Or 0.1 degrees, sorry. Then next, we're going to go to Capella now. We'll do 58.7 divided by 60. It's 0.97 times 18.2, 17. So we'll do 16.7 minus that. Gets a negative answer. So if we add 60, this comes down to 40 degrees, 58.9 minutes. If we do the 58.7 divided by 60 times 1.2, we'll get 1.17, basically 1.2. So we do 45.2 minus answer, 44. So we got 0.44 degrees, 0.0 degrees. Now we have to do it once again for Rigel. So we'll get, 13.3 divided by 60 times 28.2 gets us 6.5. So we'll do 20.7 minus answer, 14.4. So we'll keep that as 33 degrees, 14.4 minutes. And then we perform the same problem for azimuth. So we'll do 112.9 plus answer. Make sure you're always doing plus and minus correctly. You get 113.1. Good. Finally, we have to convert that to Zn. So if we open up the book, we have to remember our rules here. So, what was it? Doobie had an LHA of 319 and we're in the north. Meaning, according to the rules, LHA greater than 180, we're in the north, Zn equals Z. So Doobie, its azimuth is 23.1 degrees true. Capella had an LHA of 49 degrees. So according to the rule, northern latitude LHA less than 180, 360 minus Z. So we'll do 360 minus their Z value. 360 minus 44 gets us 316. And then Rigel had LHA of 51, so it's also going to be 360 minus. Same rules apply. So minus 113.1 gets us 246.9 degrees. True. All right. Now we have our HCs and our ZNs. Last thing we got to do for this before we actually get to plotting is we got to perform our HS to HO. I know, this is a lot of work. HS, IE, dip, HA, main, HO. I'm going to erase this because we're going to need it, the space in a second. Okay. HS for Doobie, if I look at the notes, was 38 degrees, 18.9. And before we even start, we want to make sure that's pretty close to what we got for HC, which they are pretty similar. So that's a good sign. For Capella was 41 degrees, 03.6 minutes, which is also really close. And then for Rigel was 35 degrees, 35.2 minutes, which is pretty far apart. We might have done something wrong with Rigel because this is a really large difference. So we'll see. We're not there yet. I will want to double check this in a second. Now our IE, remember I said I don't actually know if this is correct, but I think the IE, the index error is 0.3 on for this project. And our height of eye is 54 feet for all of them, 54.4. So we'll know what our dip is automatically for all three. So we'll come to the altitude correction table. We'll look for our dip, 54.4. It's down here, still further, 54.3, minus 7.2. So they're all minus 7.2. Minutes, that is. Okay, so we'll apply these corrections to both. Whenever it's on, that means we subtract the error. So we'll do 18.9 minus 0.3 minus 7.2. Gets us 38 degrees, 11.4 minutes. 3.6 minus 0.3 minus 7.2 goes into the negative, so we add 360, we get 40 degrees, 56.1 minutes. And then 35.2 minus 0.3 minus 7.2 gets us 35 degrees, 27.7 minutes. And then for our main correction, we open up to the altitude corrections again. Remember, we're going to use the star section. We come to stars and planets here. There we go, stars and planets. For the stars, let's see. For Doobie, 38 degrees 11. So if we look here, they're minus 1.2. So we just write minus 1.2. For Capella, we're looking for 40, 46. So that's minus 1.1. And then for Rigel, we're looking for 35.27. Minus 1.4. All right, we apply all of those. We get a final HO of 38 degrees, 10.2 minutes, 40 degrees, 45.0 minutes, and 35 degrees, 26.3 minutes. Good. Now finally, just to collect together our last bit of information, we're going to write down our assumed latitude, our assumed longitude, our ZN, and our intercept, which is HO minus HC. So we'll carry over. The first three are easy. Assumed latitude, we said, was 18 degrees north. I'm only compiling them all here at the end so that it's easier to recall them all when we're plotting. Assumed longitude, here we've got 161 degrees, 44.8 minutes east, 162 degrees, 22.4 minutes east, and 162 degrees, 29.8 minutes east. Good. Our ZNs were 23.1 degrees, 316 degrees, and 246.9 degrees. All true, obviously. Intercept, we're going to have to do homo-to. So we had for Doobie an HO of 38, 10.2, and HC of 37, 40.9. So we'll do 10.2 plus 60 minus 40.2 gets us 30 minutes, so 30 whole. So we had a difference of 30 between the two. Remember, HO was greater than HC, so that's towards. So our intercept here is 30 minutes towards. For Capella, we had an HC of 40 degrees 58 and an HO of 40 degrees 45. So we're going to do 58.9 minus 45 gets us 13.9. So this is going to be a difference of 13.9 minutes. This time HC is greater than HO, so we're going to do away. And Rigel, like I said, I think is wrong. We've got a difference of 33 degrees here and 35 degrees here. So that's going to give us an intercept of like, 120 something miles. I'm going to end the video here, figure out what was wrong with this, and then we're going to move forward with the other two if this one is just irrecoverable, and see if we can get something like a fix from these two.